Hi everyone, I'm Toby. In this video, we're going to talk about chemical thermodynamics. Before we get into thermodynamics, we need to talk about energy. The energy is just a capacity of doing work. It has some units like joules and calories. Energy can be in two different forms. The first form is called potential energy, which is the energy that has potential to do work. The potential energy has some examples, like electric potential energy, gravitational potential energy, and chemical energy. Another form of energy is called kinetic energy, which is caused by the motion of the object. Kinetic energy can be calculated by 1/2 times the mass of the object times velocity squared. And there are two common forms of potential energy. Electrical energy is just kinetic energy of electrons, and thermal energy is just the average kinetic energy of a bunch of particles. Alright, let's talk about work right now. Work is just the energy transferred from the object to another by the application of force along a displacement. And work is defined by the integral of force times the differential of displacement. For example, if the force is equal to 3x squared plus 2 newtons, it's along the x-axis. What is the work done by the force of from x to 0 meters to x to 3 meters? The work is just equal to the integral from 0 to 3x squared plus 2 dx, which means work is just equal to x cubed plus 2x from 0 to 3. So work is just equal to 3 cubed plus 2 times 3, which is 33 joules, because we have newtons right here, we have meters right here, newton times meter is joules. Now let's talk about chemical reactions. In a chemical reaction, the changing energy is very common. In terms of the changing energy, there are two types of chemical reactions. The first type is called exothermic reaction, which means the reaction releases heat or releases energy. Because in an exothermic reaction, as shown in the diagram, the top diagram right here, as the reaction progresses, the energy of the product is less than the energy of the reactant. Therefore, if you use the energy of the product to minus energy of the reactant, it's a negative number. So delta H, the changing energy, is less than 0. However, an endothermic energy absorbs energy. The endothermic reaction absorbs energy, so the delta H should be greater than 0 because the reactants contains less energy and products. Pay attention to the energy diagram right here. If there's a peak in the diagram, this represents the transition state of the reaction. So the reactants will always get into transition state first, then get into products. The energy difference between the transition state and reactant is called the activation energy, or denoted EA. Alright, hope that will be helpful to you. Thanks for watching and have a great day.